Hello, this is a final project for Harvard Extension School Big Data Analytics class on VoltDB, a new SQL analytics database. So VoltDB is a relational database. It's new SQL. It's in memory, meaning it is extremely fast. It's partitioned, it's single-threaded, distributed, and it's ACID compliant. And this is built for running hundreds of thousands of transactions a second. And this implements the HStore project. The architecture of VoltDB consists of a number of different elements. The first is the application catalog, which has three components: the database schema, stored procedures, and partitioning information. So the thing about the database schema is that you need to define this before you create the database, and it supports 9 basic data types for table columns, including numbers, strings, time, and binary. Stored procedures are the unit of transaction in VoltDB, and these are Java statements interspersed with SQL, and they're extremely fast in VoltDB because they're precompiled. The data that I'm using is from Cerner HealthFacts Diabetes database, and this is available from the University of California Irvine's machine learning repository. It contains over 1,000 patients from 130 US hospitals collected over 10 years. It has demographics data, diagnoses, whether they were readmitted in the last 30 days or not, medications, and other useful data elements in predicting risks for hospitalization. So the first step is to build a database schema that matches the CSV file that the data comes in. And here is an example of what that schema looks like. The next thing to do is to compile the schema into an application catalog. And once you have it compiled, you then start a new empty database using the application catalog and deployment files, which is the physical layout of the database. You then load your dataset into the tables you defined using the CSV loader utility from VoltDB. So once you have your data loaded, you can then query the data using SQL statements. There's a SQL command line prompt that you can get to, and then just write your statements, and those execute when you have a semicolon. Stored procedures are useful for queries that you run frequently, and essentially you change the value of input each time you run the query. These are precompiled in VoltDB, making them super fast to execute. You can even have them on partitions so that they run even faster. So to add a stored procedure, you add this to the database schema. And once you add that to the schema, you then have to recompile the catalog, recreate and update the database, reload or restore the data, and then run your stored procedure. The question mark in the where statement is an element that is supplied at runtime. So in the stored procedure example here, I'm supplying the value 410 to that diagnosis code and getting the results that match that query. There are some additional steps if you want to use Java for a stored procedure. You need to define and compile the Java stored procedure, and you do this in a separate .java file, and then compile that Java file, add that procedure to your catalog, and then recompile the catalog with the class path option defined. Here I have my database schema. First, there's the create table function, where I set up my table to match the input of my data. Next, I have a partition statement that partitions the table on the readmitted column. This will make things run a little bit faster when I'm looking at readmitted data. Next, I create a stored procedure, and the question mark will be filled in at runtime. And then I also have my stored procedure for a Java element as well. So now that I have my stored procedures defined and my database definition, database schema defined, the next thing I need to do is to compile that database schema. And here you can see that it compiles, it sets up my table, diabetes, and it also has information on my stored procedures here as well. The next thing I need to do is to start my database. So I use the VoltDB create command. And this will start my database. So now this will take up one window, and we will move over to another window to actually start importing the data. I use the CSV loader to import data from my CSV file that I downloaded into my dataset. I can then go and query this data using the SQL command. First, I want to take a look at my stored procedures. I give it the value of 410. And here's all the results. Next, I can look at my other stored procedure. This was diag readmitted, and give it the same value of 410. And you can see it produces pretty much the same results as we saw before. So I can select all of the rows in my dataset, and here I see I have the 101,000, which is what I expected. So the pros of using VoltDB, it has speed at scale, and this is because it's in memory. You don't have to worry about disks, you don't have to worry about buffer pools, and you have near limitless scalability because you can add additional servers and it scales linearly. This makes real-time analytics possible to do. VoltDB is single-threaded, so it's extremely fast for reads and writes, and there's no locking overhead. This is done through a scheduler system. There are ACID guarantees, meaning that your data is always going to be accurate. You can set up high availability and durability by replicating clusters and partitions, respectively. And it also uses SQL as your query language, which is familiar for a lot of people. So there are some cons to VoltDB. You need to define your schema up front, and this is a challenge if you don't know what your data is going to look like, because then you need to change your database schema to match that data, and then reconfigure, and that reconfiguration complicates things because then you need to shut down and save and restore your database. The functionality for snapshots and restores seems to be missing from the community version, although this is available in the Enterprise Edition. The database is relatively new. It came out around 2010 in its first community open source version, so there are some ease of use issues that eventually will need to be worked out. In terms of generality, when you're updating multiple nodes in a single transaction or procedure, these will not be a single partition table transaction. Also, this is designed mainly for OLTP workflows rather than reporting. I ran into some challenges in creating a new API or client to import from real-time data source. There used to be a Twitter example, but Twitter has since changed their APIs, and that seems to no longer be included in the examples that they have. So there's some resources that I found particularly valuable. There's the VoltDB University that has online tutorials on how to use VoltDB. There's the HStore paper, the University of California Irvine Machine Learning Repository, which has a whole bunch of great data sets for big data analytics. And the paper from Strack that also looked at the same data sets that I'm analyzing. And there's also another paper available that discusses the pros and cons of VoltDB.